Okay, it is till 5, so I would like to start the session. Okay, I'm Shintaro Ueda from Kyushu University. Everyone, welcome to KYUDAI Now, Bangladesh. Okay, the main purpose of this session is to get together with Bangladesh and Kyushu University, so we like to start collaborations. So for the master of ceremony, we have Dr. Asad Duzaman. Please MC the session, please.
Thank you very much, Dr. Shintaro Ueda. I would like to say thank you for arranging this in Bangladesh, the Q&A program. In this session, we would like to start opening remarks. I'd like to request Professor Akira Harata, Senior Vice President of Kyushu University, to have his opening remarks. Please, Harata-sensei.
Good afternoon. I'm Akira Harata, Senior Vice President. Oh, okay. Okay. Yeah, I'm Akira Harata, Senior Vice President of Kyushu University and Deputy Director General of Q-AOS, Kyushu University Institute for Asian and Oceanian Studies. Thanks a lot for taking time out of your busy schedule to be here to join KYUDAI Now in Bangladesh. I'd like to express great thanks to distinguished guest, Mr. Tatsuya Machida, Minister of Embassy of Japan in Bangladesh, Professor Hafez M.D. Hassanbag, Dean of Faculty of Engineering of Technology, University of Dhaka, Professor M.D. Aftab Ali Sheikh, Chairman of Bangladesh Council of Scientific and Industrial Research, Dr. Sikdar M. Asaduman, President of Kyushu University Alumni Association, Bangladesh, and especially all the participants being here or connecting online. It's our great pleasure to have this opportunity for talking about ongoing and future collaboration between Bangladesh and Kyushu University. Yeah. Right, have some trouble, but I'd like to show the I'd like to show the program, but oh, that's good. KYUDAI Now have several objectives to introduce research from researchers who are currently active actively promoting research at Kyushu University, and to build new collaboration, and to renew old friendships. Here, let me briefly introduce three distinguished topics of Kyushu University over this last decade. The first one is relocation to new Ito campus. This is a bird's eye view photo and aerial photo of the campus, new campus. Zooming up and going back to 2001, we can see no buildings, surrounded by mountains of orange groves. The relocation was completed in 2018, and there are a number of buildings, research facilities and libraries, nature preserves, and a farm. With an area of 251 hectares, it is one of the largest university campus in Japan. This is campus and dormitory map. There are 4 main campuses. Ito is the largest one I talked about. The other campus, 3 campuses in Fukuoka downtown. These are landscape paintings by Professor Tanimoto, Dean of Interdisciplinary Graduate School of Engineering Science. I hope he are planning to new international education program between Kyushu University and between Japan, Bangladesh. Q-AOS. Q-AOS was established in 2019, the year after its campus relocation, as a continuation of research and educational activities of Kyushu University in Asia and Oceania. This is thirdly important topic for me. Q-AOS aims to achieve SDGs, Sustainable Development Goals, and find future SDGs through interdisciplinary activities across academic disciplines and on-demand and on-site practices. If we search our homepage using keyword Q-AOS, you will find detailed information. There is a page on the current collaboration between Bangladesh and Kyushu University. I skipped second topics. This is the designation as one of the 10 designated national university corporations by MEXT, the Ministry of Education, Culture, Sports, Science, and Technology, Japan. In addition, Kyushu University announced Vision 2030 for driving social change with integrative knowledge. We have many goals. Among many goals to be achieved, Kyushu University has identified 4 issues of particular importance. I believe these issues, decarbonization, medicine and health, environment and food, digital transformation, are highly common and interest of all of you. If I have enough time, I show you a promotion video, but I'd like to skip this. Oh, this is a little extra. Here, I'd like to introduce Kyushu University Fund, which is also used to support international students. Donations are very welcome, and you can check Kyushu University homepage. Now, I'd like to conclude my opening remarks by hoping that this meeting will prove meaningful for all the participants and new collaboration will start. Thank you for your attention.
Thank you very much, Professor Harada, for your nice presentation to know about the activities of Kyushu University. Now, I would like to request Mr. Tetsuya Machida, Minister, the Embassy of Japan in Bangladesh. Please deliver your speech.
Professor Akira Harata, Senior Vice President, Kyushu University. Professor MD Aftab Ali Sheikh, Chairman of BCSIR. Professor Shuji Shimizu, the Vice President, Kyushu University. Professor Hafiz MD Hassan Babu, Dean, Faculty of Engineering and Technology, University of Dhaka. Professor Bijut Baran Shaha, the International Institute for Carbon Neutral Energy Research, as well as Dr. Shikda M. Zaman, President, Kyushu University Alumni Association, Bangladesh. Ladies and gentlemen, thank you. Good morning. Thank you very much, me too, providing me that opportunity to speak in front of you. Ambassador Iwama has also conveyed me to send his best regards. He's now on the way for the indispensable the business trip where he couldn't actually change his schedule. But this is very much of my ambassadors and my embassy's hope that the people to exchange between Japan and Bangladesh is going to be deepened. I'm very happy to know that Kyushu University is proud of a tradition having the collaboration with various universities in Bangladesh, starting from University of Dhaka, as well as the university itself is even eligible for so-called YLP program, Young Leaders Program, where there is already that alumni and the students studying at the Kyushu University. We have had since several years that tremendous progress of the bilateral relationship that we have last year upgraded the Japan-Bangladesh relationship from the comprehensive one to strategic one, meaning that there is going to be the whole range of the possibility to work together, even to not to just to bound to the political or economic ties, but especially, as I said, that people-to-people exchange. Japan itself hopes the able Bangladesh youngsters to come to Japan, learn, study, and contribute to the further development of the academics in Japan. On the other hand, Bangladesh needs the qualified the youngsters who is going to contribute to the country in future in a substantial manner. In this sense, I'm very happy that Kyushu University has initiated such an event to even to promote the existing ties with the alumni, but also the finding the new ways of collaboration with their counterparts in Bangladesh. The Kyushu is known to be located the gateway to the entire Asia from Japan, that rich in history and has a very strong ties with the neighboring countries. Bangladesh itself is known to be that core of the intellectual production in sub-Indian continent. And as you might know that, the Dhaka is a kind of mecca of the universities where that many the foreign students in the surrounding countries are even studying. So I hope that the synergy is going to be created through the collaboration of between Kyushu University and Bangladesh universities. And I hope a lot of vibrant discussion and fruitful communication amongst the participants in this afternoon. Thank you very much.
I'd like to take a prevalence. I would like to request Professor Akira Harata to give a thankful gift to Mr. Tatsuya Machida. Please, Harata Sensei and Mr. Tatsuya Machida, please. It was looking good. We are very happy for it. Now, I would like to request Professor Muhammad Aftab Ali Sheikh, Chairman, Bangladesh Council of Scientific and Industrial Research, to deliver his speech. Mr. Sheikh, please.
Thank you very much, Dr. Asadul Zaman. He is the president of Kyushu University Alumni Association. Thank you. Very good at anchoring. Okay, so thank you very much. This is a very good feeling of mine here, because when Professor Dr. Udit Shah, our very dearest professor, and also the alumnus of University of Dhaka requested me to deliver my introductory remark here in this program, I was very much happy to come here. Thank you very much, dear Shah. So, KYUDAI now in Bangladesh, the opening ceremony of this seminar organized by the Kyushu University Forum. Here we have very famous dignitaries here. His Excellency Mr. Tatsuya Machida, Honorable Minister, the Embassy of Japan in Bangladesh. Also, we have from the Kyushu University, Professor Dr. Akira Harata. Sometime before he talked, very nicely described his institution, different activities. Senior Vice President, Kyushu University. Also, Professor Dr. Hafiz Mohammad Hassan Babu. Yeah, he's here. Sometime before came with Professor Istiaq, Dean Faculty of Science and Engineering, University of Dhaka. He has a very busy schedule now because the admission test of Dhaka University is going on. He is very busy with this thing. He is the boss of this admission test at this moment. And also we have Professor Suji Shimizu, Vice President of Kyushu University, we have another dignitaries, was Dr. Subroto Kumar Aditya. He, some months before, he was the treasurer of the Sheikh Hasina University and also the professor of Tripoli of Dhaka University and all other dignitaries. We see a good number of PhD holder from Kyushu University also working there in Dhaka University and other university here, and also the dignitaries from Japan and also Kyushu University. So this is my privilege and honor to be here and talk a little bit about the Kyushu University, Bangladesh Council of Scientific and Industrial Research, Dhaka University, and also the different collaboration, Vidyut Bhavan Shah, etc. So yes, first of all, I'd like to congratulate all the members of this program who materialized this program at this stage. And also, I would like to thank Japanese government, because after our liberation in 1971, they probably one of the first country declare us as the Bangladesh. So we're very happy. And there is a very big relationship between whether it is economic, whether it is educational, whether it is scientific. There is a lot of relationship between different university and the Japanese government and Bangladesh. So we are very happy. And at the first step of my talk, I would like to show the profound gratitude to the father of the nation, Bangabandhu Sheikh Mujibur Rahman, who is the founder of this country. And also, I'd like to tell about a little bit Kyushu University, though I don't know many things about this, but I saw at least 10 teachers of Dhaka University. They completed their PhD degree under the supervision of Professor Vidyut Bhavan Shah and other professors there in the Kyushu University. This must be, the salute must be given to Professor Vidyut Bhavan Shah and other professors of Kyushu University. And also, probably I heard that about 100 of the PhD graduated, they did their PhD from Kyushu University. So there is a very big respect must go to them, the professors and the authorities of the Kyushu University. And also, so right now it is the Imperial University of Japan. And yeah, it's a very big acknowledgement about this university. And the thing is that the BCSIR, where I am the chairman of BCSIR, actually I'm the professor of Department of Chemistry, University of Dhaka. Now I am responsible for the activities and other thing observed by as a chairman of BCSIR. And you know, BCSIR at this moment we have 400 scientists. They are very much qualityful scientists, probably I see, because after the passing of MSc and BSc of different various University of Bangladesh, they can be selected to be the scientist of BCSIR, and then they went to or go to different big or famous university to complete their higher studies and then come back again. And our main job there in the BCSIR is to do some scientific research that can be helpful for the industry. And then the industry produce larger scale of this material or the product, and this go to the market, and people will get the help from this industrial product. Though most of the product are coming from different several country, but some of the product we can produce there. Some activities that is very much needed to focus our scientific arena, that we are doing. And this is the prime institution of the Bangladesh government, a prime research organization of Bangladesh. And most of the cases, the student of differentiable public university or private university in Bangladesh, they do not have the very much nice or very good instrumental facilities there in university. Most of them, they go to the BCSIR to get the instrumental facilities, and our scientists and we help them to materialize their research work, especially the MS and PhD research work. So there is a very good opportunity us to uh, uh, produce some of the relationship between the Kyushu University and also the BCSIR. I am requesting the Vice President, although Bidut Barun Shah, please make an appointment to produce one of the memorandum of understanding between the BCSIR and Kyushu University. And we are talking about the University of Dhaka. University of Dhaka is the prime university of Bangladesh, and I know there is a very good relationship between the Kyushu University and University of Dhaka. And I am expecting that with this program, we can again increase our relationship between the University of Kyushu University and University of Dhaka, and even the BCSIR. This triangle relationship, the University of Kyushu University, University of Dhaka, and also the BCSIR, we get some of the memorandum of understanding, and through this relationship, we can then, as a very good friend of us, but Japan can help us. And also, I can remember Professor, our Honorable Prime Minister, Sheikh Hasina, her last visit, she also emphasized about this scientific relationship between Japan and Bangladesh. So, yeah, this is a good feeling. And also, I'm a little bit talking about the Bidut Barun Shah's activities. Already, we have a talk between him and me to especially increase the relationship between this Kyushu University and BCSR. And probably from this meeting, we can announce, maybe we can announce to increase their relationship between the BCSR and also the University of Kyushu University. And also from our BCSR, we can announce that there is a very big BCSR Congress. It will be happen in 8 to 10 March of this month. And Professor Yoshinari Osumi, who got the Nobel Prize in 2016 in medicine, he will deliver the theme lecture of the conference. And I am inviting all the scientists and dignitaries to attend this program. And I have some invitation letter here. Some of, probably 2 or 3 I distribute. So it is not required to distribute all the invitation card to you. And you are requested to come to join this conference, because this is first time in the history of country, 15 parallel sessions will be happening simultaneously 3 days in this conference, and 1,050 scientists will join this program. And with this little talk, I would like to thank again to this Kyushu University because they invited me to talk a little bit. Thank you very much. Have a nice time.
Thank you. I would like to request Professor Akira Harada to give thankful gift to Professor Aftab Ali Sheikh. Thank you very much. At this stage, I would like to request Professor Hafiz Mohammad Hassan Babu, Dean, Faculty of Engineering and Technology, University of Dhaka, to deliver his speech. Please.
Thank you, Professor Asaduzzaman. My voice is little bit distorted, so I am extremely sorry for this. Konnichiwa. When I see Japan, I feel my presence in Japan as well as Bangladesh. Watashi wa Ionen han Kyukodai de benkushimashita. I have completed my education in Japan in 2000s. And then I back to Bangladesh. I started my journey in Bangladesh with Dhaka University. Anyway, today we have many respected people here. Mr. Tatsuya Machida, Minister, the Embassy of Japan in Bangladesh. Akira Harata Sensei, Senior Vice President, Kyushu University. And my favorite person, the Professor Aftab Ali Sheikh, is also present here. And we see many other respected guests who will talk in the different sessions in today's occasions. Vidyut Bharan Saha, Professor Vidyut Bharan Saha Sensei, he was working extremely hard before your presence in Bangladesh. We had a very long discussions. And at this moment, our Honorable Vice Chancellor of Dhaka University is waiting to see some fruitful discussion and progress with the Kyushu University. So far, I know that just 1 or 2 days back, he was talking one of the secretary of the planning divisions, how this planning can be implemented in Bangladesh. And that secretary in front of me, he assured Honorable Vice Chancellor that the government will help without any reservations. So thank you. And at this moment, you know that Bangladesh government, Bangladesh Honorable Prime Ministers, she has a very strong dream about the implementation of a smart Bangladesh. And it is our actually pride that Japan is our close friend. And Japanese government is actually extending their hands to implement the theme of the current government. And Dhaka University is one of the important location because you know the most of the dignitaries who are running this country are from Dhaka University. Honorable Prime Minister, she is from Dhaka University. Honorable President, she is from the Dhaka University. Honorable Chief Justice, she is from the Dhaka University. Honorable Speaker, she is from also the Dhaka University. So the most of the renowned people who are actually leading this country, those people are from Dhaka University. So we feel this will be the good chance of Kyushu University to make the strong relationships of the #1 university of Bangladesh, that is the Dhaka University. And in Dhaka universities, there are many more faculties, many more departments that we had already talked with the Sensei, that we are making some planning, making some theme so that we can implement this project under the leaderships of Kyushu University and Dhaka University with the help of our governments. And here I see that one of the director of Dhaka University, Professor Ishtiaq Moin, is present. He's running one of the important research institutions of Dhaka University. That is the Center of Excellence. And there are many other foreign researchers also doing the researches in that particular institution. And you also visit. So far, I know that you have that trip to that particular institutions, and he's also waiting to receive you in his institutions. And my actually, as being the Dean of the Faculty of Engineering and Technology, we have 5 departments there. one of the computer science and engineering, electrical and electronic engineering. We have the nuclear engineering department. We have the applied chemistry and chemical engineering department. And last, we have the robotics and mechatronics engineering departments. So far I know that during my stay, about 4.5 years in Japan, Japan is technologically so advanced country. And we people who have the knowledge, who have gained the knowledge from Japan during our PhD programs and master's program, we are actually waiting to get your help to establish this country, this especially the beloved institution of Bangladesh, this is the Dhaka University. And I hope that in this trip, you will be successful to make your planning by making the MU and implementing the JICA implemented project in Dhaka University. So thank you all. I wish you good luck, and I also inviting you to my faculty during your stay in Dhaka. Thank you. Thank you all.
I would like to request Professor Shoji Shimizu, Vice President of Kyushu University, to hand over thankful gift to Professor Hafiz Mohammad Hassan Babu. Thank you very much. Now, it's the time we'll have a little different issue. The topic is introducing Kyushu University and Institute for Asian and Oceanian Studies. This topic will be delivered by Dr. Shintaro Ueda, Research Lecturer, Kyushu University Institute for Asian and Oceanian Studies. Please, Dr. Shintaro Ueda.
Okay, thank you. I'm Shintaro Ueda from Kyushu University, and I would like to introduce our university and our institute. First, where is Japan located? And here is Japan, and Bangladesh is over here, and Tokyo is here, and Kyushu Island is the southern island in Japan, and Fukuoka is located in Kyushu Island. And the distance from Fukuoka to Bangladesh is 4,766 kilometers. And the flight time from Fukuoka to Bangladesh was 10 hours and 40 minutes. We transited at Singapore, and okay. Now I'd like to introduce Fukuoka City, where Kyushu University is located. Fukuoka City, the population is 1.5 million. It's the largest city in Kyushu Island and the sixth biggest city in Japan. Fukuoka is very popular for its delicious ramen noodles, yakitori chicken, yatai, sakura, cherry blossoms, and active summer festival, Yamakasa. And Fukuoka City is a city that you can enjoy urban city and nature in one. So this is a picture of Ohori Park and the coast of Fukuoka. So I hope you have a chance to come to Fukuoka one day. Okay, and in Japan, the major cities, the population is decreasing, but in Fukuoka, the population is increasing. It's the increasing rate is number one in Japan, and especially for the young generation. So if you decide to study in Kyushu University, you'll be in the city that is growing in Japan. Okay, as Senior Vice President Harata Sensei mentioned, we have 4 campuses. One is from the west is the Ito campus, the main campus where most of the departments and headquarters is located. And in the east, there's Chikushi campus where the Interdisciplinary Graduate School for Engineering Science is located, and the Midas campus where the Faculty of Medicine is located. and Ohachi campus, where the faculty is the design is located. And Ito campus is the largest single campus in Japan. Now I would like to talk about the ranking of Kyushu University. It is 4th in Japanese university ranking, and in the KYUDAI World University ranking, it's 124th, 29th in Asia. And now I would like to talk about the number of students and faculties in Kyushu University. The total number of students is over 18,000. This is including both undergraduate and graduate students, of which 9%, 2,000, over 2,000 are international students. And there are over 2,000 faculty. This includes 115 non-Japanese faculty. And there's 12 undergraduate schools and 18 graduate schools, starting from humanities, law, science, engineering, design, agriculture, vast variety of schools. And here are the statistics of Bangladesh students in Kyushu University. There are 43 students. Most of them are graduate school, and of which most are from the Department of Engineering, 18, and interdisciplinary graduate school of engineering science is 13. And Kyushu University Alumni Association Bangladesh was officially registered in May 26, 2021. And the president is Dr. Asad Duzman. And I will skip the short video of Kyushu University. And we have many partner institutions. As in the opening session, we have University of Dhaka, North-South University, BUET, Bangladesh Agriculture University, Premier University, Bandhu University, and Leading University. Now I would like to talk about our institution, Institute for Asian and Oceanian Studies, Q-AOS. Q-AOS has 3 major concepts. One is to promote interdisciplinary activities. We will act as a hub to collaborate between many departments, government, and corporations. And we carry out on-demand, on-site research. We carry out the research where the action is actually happening. And we have the concept of doing research and education to meet the SDGs for 2030 and the future SDGs. This is the organization structure. President Ishibashi is the Director General. Senior Vice President Akira Harata is the Deputy Director General. And Vice President Shuji Shimizu is Executive Research Director. And in Q-AOS, there are 6 clusters from a vast variety of specialties, starting from resource recycling to cultural variation. And in the clusters, there are 4 to 5 modules, so the total of 25 modules. And in one module, there are about 10 members, so over 250 members in Q-AOS. Now I'd like to talk about the activities of Q-AOS. One is the brown bag seminars that we carry out on Wednesday, every Wednesday from 12:10 to 12:50, which is lunch break in Japan. So it will be 9:10 to 9:50 in Bangladesh. Its purpose is to share information of cutting-edge research to inside and outside of Kyushu University to have collaboration between researchers. For example, Shaha Sensei gave a talk about carbon neutral energy society, which is on science and engineering. And Professor Yokota gave a talk about developmental disorders, which is humanities. So a vast variety of topics. And tomorrow, Professor Kimizuka will talk about up-conversion molecular systems, which is science. So you're all welcome to join this brown bag seminar. Next is Asian Week. We carry out Asian Week every November. The aim of Asia Week is to connect Asian countries and institutions to promote collaboration. For example, I organized a session on research and education opportunities between Kyushu University and Bangladesh, where the researchers from Bangladesh and Kyushu University gave a talk about the research, and both embassies gave explanation on the support that they give to the overseas exchange students. Last is the KYUDAI Now forums that we are carrying out right now. These are to connect alumni from all over Asia. And in the past, we had KYUDAI Now in Indonesia, Vietnam, Thailand, and Malaysia. Throughout these forums, we aim to collaborate to achieve SDGs and realize sustainable society. Thank you. And through the forum, we would like to collaborate more. Thank you very much.
Thank you very much, Dr. Shintaro Ueda, for your nice presentation. Now, I would like to request to put ourselves in a frame. Please come for group photo.
Okay, so everyone, can you come up to the stage for taking a picture? And the members that gave opening remarks, can you be in the center, please? Okay, please on the stage. Bangladesh session. Yeah, thank you very much. Okay, everyone, please come to the stage. And
I think সামনে দাঁড়াবো সেটা ভালো আমার নাম তো দিল
hello, can you speak? 3, 2, 1, cheese. Oh, why not? Thank you very much.
Thank you very much. It's a request. Continue the next channel. Yes, please. Continue.
Continue what?
Or is it?
He will give a presentation?
No. That's instead of me, he will continue.
Oh. So he will give a talk? Oh, okay. 15分ですよ。はい、お願いします。はい。
上田先生、ちょっといいですか。これでこっちか、左右。
どっちでもいいか。 はい、すみません。
あ、はい。
はい。お疲れ様です。Okay, I know everyone is kind of busy, but please have a seat.
Hello, good evening. Myself, Dr. Mutakin. I'm currently serving as the Associate Professor in Department of Mechanical and Production Engineering of Ahsanullah University of Science and Technology. My primary identity here is I'm a KYUDAI graduate, and I'm honored to be chairing this session. So first, I'd like to ask Takako Suzuki Sensei. She is the Associate Professor of Faculty of Languages and Cultures, and she will give a talk on education and international development, longitudinal studies to evaluate non-cognitive skills gained through primary schools. And I'm asked to mention that each talk will be of 15 minutes duration, and after each talk, there will be a 5 minutes Q&A session. Okay, Sensei.
Thank you very much. Good afternoon, everyone. My name is Takako Suzuki, and I'm going to introduce my research today. And before that, let me introduce myself first. I belong to 3 institutions at Kyushu University at the moment. Faculty of Language and Cultures, as presented, and Graduate School of Human Environment Studies, which covers Education Department. And Shiki and Yunus Social Business Research Center. Here, something related to Bangladesh. Our nominal director is Professor Yunus, and I'm a starting member of this research center. And when it's established in 2011, I came to Bangladesh and visited Grameen banks and related business sites, as well as famous black schools. My specialty is education, and especially education and international development. My main concern is to address to the Sustainable Development Goals, Goal 4. So that's why I'm looking at remote schools or rural schools or small scale schools, especially in South Asia, Africa, and South America. And in education, I'm especially looking at primary education and a little bit of secondary education as a basic education. And then, later I'm conducting researches in Myanmar, Nepal, Zambia, and Colombia. And today I'm going to introduce my research conducted in Colombia, because this is international collaborative research with professors from several universities in Japan and universities in Colombia, and also NGOs. So one of the objectives of this seminar today is to collaborate and seek for the future joint researches or collaboration. So I'm going to introduce my current international collaborative research. I'm talking about Escuela Nueva in Colombia, in South America. Have you heard of Escuela Nueva? It's a Spanish word meaning new schools. And this is more like, so I'm going to show you some of the images. This is an example of Escuela Nueva. This is a rural school, small scale school, and it's often one teacher school. In the middle, this is organized by NGO. So it's a little bit similar to black schools. And students don't sit down in the traditional row, just like you are doing now, right? And students are sitting in groups and working together. And, and there are several grades together in one classroom. And you see the lady, this lady in the middle of the classroom, she's a teacher, but in Escuela Nueva School, well, she's not called a teacher, but she's called a facilitator. She doesn't really teach, but she facilitates or coordinates students to assist, help students learning. And normally students are working together with a group, or sometimes with different age students or children. And there's a learning material guide. So according to the material guide, they learn by themselves. And well, this is another example. Escuela Nueva normally has resource centers and library corners. So this way they can use materials like references, like dictionaries, and these days maybe IT tablets. And well, this is very famous school innovation, just like black schools in the world. So they have a good reputation of mathematics and languages as academic skills. But at the same time, they emphasize the non-cognitive skills, which is like problem solving or self-esteem or collaboration or, you know, open-minded or something we require for the 21st century. That's why we decided to conduct the research in Escuela Nueva. We have two research questions. One is, did the graduates of Escuela Nueva primary schools gain non-cognitive skills as a grade 6 right after their primary education in 2014? Second, can we see the same impact when they became a grade 9 after 4 years of secondary education in 2017? And we used the indicators to explain non-cognitive skills out of literature review. We reviewed the literature. And we selected 3 indicators: autonomous learning, self-esteem, and civil behavior. And we conducted the research to measure these 3 indicators. And as a research tool, we established the questionnaire out of the several literature. And this is Colombia. I don't know if you're familiar with Colombia, but it's located in South America, but top of the continent. And we selected 2 departments, Antioquia and Quindío department, because they are right on Andes mountain range, and they have lots of coffee plantations. So but normally in the plantation areas, going to school is very difficult for children because their parents are like seasonable laborers. So they follow the harvest of coffee. And normally children had to leave the school or move school to school, or sometimes they have to help their parents to pick up coffee beans. So there are lots of small scale schools in this area. That's why we selected 2 departments. And we selected 19 secondary schools in 2 departments. And our sample are 965 students who just graduated from primary school. And we provided a questionnaire to grade 6 students. And 965 students answered. And we provided exactly the same questionnaire to the same students 4 years later to compare 2 data. We couldn't find exactly same students because, as you know, well, quite a number of students drop out in secondary schools, or they move schools, or they go to urban areas, or, and especially seasonal workers, they move a lot. So we couldn't find the exact number of students, and also the number of students is decreasing. But at least we found 305 students matched from 2004 data set. So we compared two data sets. When we conducted the research in 2014, unfortunately, we didn't see the impact of primary school in civil behavior and self-esteem. But we could see autonomous learning, the impact, positive impact of autonomous learning. Therefore, we decided to continue the longitudinal study in 2017. So today, I'm going to introduce you about the result of autonomous learning. Well, SQL River is initiated by NGO, just like BRAC here. But these days, government of Colombia decided to introduce all SQL program to all primary schools in the nation. So that's why all of rural primary schools are SQL River, actually. But it depends on the implementations, how they follow the implementations. That's why we divided into 4 groups. The lower one is that lower schools didn't implement lots of SQL Nova components. And right-hand side, this school implement nearly 100% of SQL Nova implementation. So we divided into 4 groups and compared how autonomous learning was impacted among these 4 groups. And we use the 3 kinds of research analytical methods. Factor analysis to identify internal factors. That means what can be explained, what factors can explain autonomous learning. Well, what does autonomous learning mean? So we identified factors to explain autonomous learning. And analysis of variance to see the impact of internal factors, and the correlation analysis to examine the external factors of autonomous learning. Out of factor analysis, we identified 6 factors to explain autonomous learning, right? So autonomous learning could be explained by these 6 components, 6 factors. Academic and personal support, cooperation, initiative, learning, and motivation, and heterogeneity. Heterogeneity means how you can accept diversity, right? How you can be open to others, but, accept the differences. And then secondly, we conducted the analysis of variance, how this, how they have the impact on how the SQL River can make impact on these 6 factors. But this is the average of total of 6 factors as autonomous learning in total. And you see left-hand side, this is in 2014 when students are at grade 6. And the right-hand side, it's in 2017 when students are grade 9, because grade 9 is the final year of secondary education. And you see somehow they have positive impact right? Because left-hand side is lower implementation and right-hand side is higher implementation. So you see, if we conduct Escuela Nueva implementations, autonomous learning is also increasing. So that means they have positive impact of the innovation or implementation. And in 2017, also somehow we see the positive line. And when we see 6 factors, we also see more and less positive lines of the impact. However, when we see the data closely, only these 1, 2, 3 indicators and total of Escuela Nueva had the positive impact, statistically speaking. It was not really meaningful. So when we look at this, we had only few impacts. Well, this is comparison between 2014 and 2017. Right, Escuela Nueva total, well, in 2014, when students just graduated from primary school, they had positive impact of autonomous learning. And among autonomous learning, 3 components had positive impact. Initiative, motivation, motivation, and heterogeneity. We see positive impacts on these 3 indicators. But when we see the data in 2017, most of the impact was disappeared. We didn't see it, except initiative. Well, initiative had some kind of statistically meaning positive indication, but otherwise we didn't see any positive impacts. So the impact was gone during these 4 years of secondary education. And then we controlled outside of the Escuela Nueva impact. If we see different impact of Escuela Nueva besides Escuela Nueva. So education modified. Right. We did the correlation analysis in 2014 and 2017, and we had the variables of Escuela Nueva, and then independent variables of Escuela Nueva, and dependent variables are mother's education, household position, school location, if it's in urban or rural, or age and gender, and repetition. That means school academic achievement, how they are good at academic. So we controlled with these external factors to see the Escuela Nueva's impact in autonomous learning. And once again, well, when we see the old data, well, we couldn't see any statistically meaningful score. So basically speaking, we didn't see any impacts. But when we closely look at the results, well, autonomous learning had a positive impact in 2014 when they just graduated from primary school. But in 2017, there was no impact, nothing. We didn't really see anything. And in 2014, at grade 6, we had a correlation between Escuela Nueva and initiative, and Escuela Nueva and the heterogeneity. But we didn't see other relations. But we saw other things like position, like household assets. That means like rich or poor, or gender, or female had a positive attitude and the area, rural or urban. But these external factors impacted a little bit, but not really as good. But when we did the same research in 2014, when they became grade 9, well, we didn't see no escuela nueva at all. We didn't see any impacts of grade 6. And so we conducted with this result. Well, autonomous learning could be explained by these 6 factors, but there's no correlation except initiative when they became grade 9. And so the impact of pedagogical innovation, that means the impact of Escuela Nueva disappeared throughout the conventional secondary education because secondary schools are located in urban areas. And also secondary education is traditional. That means they sit down like row as you are now. So it's a lecture type of teaching and no moving, no collaboration, no group working, just to listen to the lecture, just like you are doing now. So with this kind of education, erased all autonomous attitude. So we recommended expand this kind of primary innovation up to the higher level of education, like secondary or high school or even universities, or at least we should include this non-cognitive concerning activities, not just listen to the lectures or like follow or obey the teachers. That's why now we are continuing this research and we are looking at the higher sectors. Because Escuela Nueva as an NGO introducing Escuela Nueva models in high school and even universities, some of universities as a pilot. So we continue to seek these students' path and we see the impacts in a higher level of education. And especially we asked their motivation or their dreams when they're grade 6 and 9. And we see how they live in the society or in the life, in the reality. So that's what we are doing at the moment. But I don't know what time is it. Is it time? Okay, thanks. Right. So I hope we can do something meaningful in Bangladesh with Kyushu University or faculty members or someone who are interested in education to collaborate to do something better to meet SDG goal 4 together. Thank you very much for listening.
Thank you, Sensei, for the wonderful talk. Now the forum is open for questions. Yeah, one question. Okay.
Thank you very much for excellent presentation done by Professor Suzuki. I'm a professor of international business at the University of Dhaka. Osaka Dagogara Shotsugushi Master said Ninenni. Just I would like to ask you one question. You did not mention the cost comparison. Say traditionally school, we have certain amount of cost. And if we go for the special one, school labor, something like that, what's the cost differences? Thank you very much.
Shall I answer
please.
one by one? Right, thank you very much for the question. And actually, I'm from Osaka. So I'm glad you studied there. Did you like Osaka? Yeah. I'm glad. Right, thank you. Well, Escuela Nueva is promoting, how how can I say, like a student-centered or student-oriented, it's called. So actually, teacher doesn't really teach, but in the secondary school, teacher teaches, and students listen to. And Escuela Nueva students, well, for example, if you visit Escuela Nueva, any Escuela Nueva, students will introduce their schools or guide you or explain something, and they have student committee, and they have roles, and they have lots of how can I say, lots of innovations, lots of systems for students to control, students to manage the school. So that's why I think it's different. And also they have different ages. So, they are tutoring the other students, and they are teaching, or they're discussing together in a classroom. But in a secondary education, the teacher talks and the students listening with silence. So, these kind of, tiny things are making difference. Am I answering the question?
Which one is more expensive?
Expensive, the cost.
Traditional or
well, speaking of the cost, because the government are using a unit cost, right, as any school systems. So like it depends on the number of the students, because we count students' cost with per head, right? So it depends on the number of the students. And small schools have fewer numbers of students. That's why the budget is lower. But actually, it's not expensive, because you see the resource center is just like this. You just put books. They don't need a big library, but they just have a corner with several books. Or they don't have a tablet for every student. They have maybe 2-3 tablets, and they share. So I don't really think Escuela Nueva is expensive.
Okay.
But it's very different to compare, because secondary education, normally higher education is more expensive. You see lots of professors from universities. Universities are more expensive than primary schools. So in that sense, secondary education is higher. But if you compare in the same level, Escuela Nueva and traditional, I don't really think Escuela Nueva is more expensive, because you don't see lots of facilities.
Okay. Thank you, Sensei. I'm sorry we cannot take any more questions because we are already running behind schedule. But we have a networking session, so if you have any question, Professor is here. You can reach out to her. Next, I'd like to introduce Yoshinori Hamamoto Sensei. He is the Associate Professor of Faculty of Engineering. The topic of his talk will be Smart Thermal Energy Conversion Technology using Solar Heat. The stage is yours.
Thank you, Chairman. Good afternoon, everyone. Today, I'm Yoshinori Hamamoto from Department of Mechanical Engineering. Oh, sorry. Oh, sorry. Laser point. Thank you. Sorry. So today I'll talk about this topic, and these are contents of my talk. Firstly, let me introduce myself briefly, and second one is Smart Energy Utilization Plant Factory for cultivation of leafy beverage vegetables. This photo is our demonstration plant in Fukutsu City in 2012 to 14. And third one, the high temperature solar heat conversion system combined with adsorption heat pump. So the firstly, the things of my interest is fishing and traveling, cycling, and stargazing. And research interests include thermal energy conversion technology based on heat and mass transfer of multi-phase change process with vapor adsorption phenomena. I spent 9 years as a student at Kyushu University completing my doctoral course. After that, I worked as a researcher of Japanese Science and Technology Agency in 2000. And from 2001 to 2005, worked as a research associate in Faculty of Engineering in Tokyo University of Agriculture and Technology. At that time, I came Dhaka to join the International Conference on Thermal Engineering with my colleague, Dr. Alan-san. At that time, I visited and meeting with Professor Anwar Hussain of the Department of Mathematics, University of Dhaka. Okay, the first topic, the smart energy utilization plant. This is a picture of the system. This is a solar collector. This collector provides the hot water at 80 degrees C flow into this adsorption chiller. This adsorption chiller provides a chilled water here. This chilled water flow into the solution heat exchanger. At this point, this hydroponic nutrition solution flow into this heat exchanger. This solution temperature is controlled by this chilled cold energy. And this one is a small energy type cultivation system. This is a plant. And this is a balloon type solar heater collector. This one is developed in this project. And this is adsorption chiller and boiler and storage tank. This figure shows the estimated result of chilled and hot water supply potential from adsorption system. This is a monthly amount of the energy from 100 balloon solar collectors. This line shows the collected solar heat. This energy can be converted to the hot water and the chilled water. The annual hot water supply is 163 gigajoule, and chilled water supply 112 gigajoule. Then the corresponding value of heavy oil was 4.2 kiloliter per year and 2.9 kiloliter per year. And this is a small energy type cultivation system. This is a locally enclosed growth environment control chamber. The space can be controlled at a low cost in an environment optimal for plant growth. And the carbon dioxide can be controlled locally around the plant. As a result of the cultivation test, the spinach at the 35% yield increase, like this. To realize this kind of plant factory, it's necessary to develop the refrigeration air conditioning system that contribute to reducing environmental managing costs, and to develop this cultivation system that contribute to the improvement of productivity and energy saving, and promotion of balloon type solar collector and adsorption chiller by reducing those costs. Currently, we are continuing our effort to create a venture company that will sell the systems and elemental equipments. And next topic shows the high temperature solar heat conversion system combined with absorption heat pump. This picture shows the heating equipment stocks by type from 2020 to 2050 reported by IEA. The solar thermal is the preferred renewable technology for water heating, especially where the heat demand is low. It meets 35% of demand by 2050, up from 7% in 2020. However, the solar thermal energy is affected by day and night and weather and regional differences. So it's necessary to develop technology to use it effectively. The application and usage temperature are generally from 40 to 200 degrees C for industry process heating and above 200 degrees C for solar thermal power generation. To expand the application of solar thermal energy, it's important to increase the heat output at high temperature. This shows the solar collectors type, this one. And this is a working temperature. So flat plate type were used for obtaining a low temperature level. It has been well introduced commercially. And usually this concentrating type is used when the temperature level is above 100 or more higher. But installation cost of this type is expensive. So the market require a low-cost solar collector with well thermal efficiency. Then aims of this research is to propose a heat supply technology up to around 200 that combined a heat collector and an absorption heat transfer cycle, a heat transformer cycle, and to predict the heat output performance considered by meteorological data. This shows the outline of proposed system. This part is solar collector, and this part is absorption heat transformer cycle. The solar collector gather the heat at what temperature at THW. This hot and amount of heat is QHW. Then this hot water flow into the evaporator in the cycle. This evaporator releases the refrigerant vapor. This refrigerant vapor flow into the adsorber. In adsorber, there are packed many adsorbent particles. When the adsorbent absorb the water, refrigerant vapor, the adsorbent release the heat of adsorption. At this temperature, TU is higher than this one, and obtained amount of heat is this HE. This energy is useful. But unfortunately, this system is batch type. Therefore, this adsorber must be dissolved like this by using this hot water from collector. And this shows the result of calculation. So amount of heat output, this HE per hour of the day. The calculation condition is that collected heat, this one, QH here, almost 200 megajoule like this was used, and then the heat is converted at 180 degrees C like this. So it means that 30% of QH was converted to this HE. And this shows the influence of output temperature TU on the output heat HE, this solid line. Here is in winter season. This is in summer season. So this HE was 2.9 times that of the collector heat, this one. And in August summer season, that is 1.5 times. So, but on the other hand, when this TU was below 160 degrees C, around here, this output of solar collector was larger than this system HE. So the effectiveness of the system was confirmed when TU was 160 degrees C or higher temperature. And even at the temperature of 200 degrees C or higher around here, this which was a temperature range where it was impossible to output heat with a collector alone around like this. This system could output heat at 210 degrees C by using the heat from the collector at 180. So in the conclusion, this system could provide higher heat than the collector alone could provide. In future work, I try to demonstrate absorption heat transformer cycle and research on system operation control method that respond to fluctuating heat correction amounts. Thank you for your kind attention. Thank you.
Thank you, Sensei. Any question, please?
Thank you for your nice presentation. I am Alom. I have studied in Kyushu University. I have a question. Is it possible to use this solar energy, thermal energy, to ionize hydrogen in the water system or something like this, so that you can use we can use this hydrogen in the hydrogen fuel cell or in the hydrogen as the solution in the is it possible to
Is it so you mean
use this thermal energy to hydrogen, separate the hydrogen from water?
Convert the
Yes.
hydrogen?
Yes.
Yeah. Hydrogen is a secondary energy, so it's difficult to make heat. Probably it needs probably I think it needs to some kind of chemical reaction and catalysis. So it's
because
useful.
when we can study in the water, like then there are some free hydrogen ion in that system, so pH is balanced or something like this. So we can use this heat energy to make more, because whenever there is a sun in the environment, sunlight, it creates some sort of ionization hydrogen in the water. Percentage is very low, and we can collect those hydrogens. So if we can use this heat in the hydrogen part, then we can actually get the hydrogen ion with a small electron volt, applying a small electron volt, not that much. So that energy will be actually converted in the fuel cell or in the hydrogen storing capacity, or in the burning the hydrogen itself.
Okay, thank you.
So is it possible? Is Japanese doing in that part research? Like?
It's difficult question. Sorry, but
thank you.
Okay, thank you.
Thank you. I'm sorry, we are only allowing one questions now. It's my pleasure to introduce our final speaker for this session, Bidut Baran Saha Sensei. He's the professor of International Institute for Carbon Neutral Energy Research, and his topic is research on energy efficient alternative cooling systems. Yes.
Thank you, Dr. Mutakin. I think this is the last talk before the tree break. So I will talk about energy efficient cooling system, and our laboratory is opposite with my family name, but in fact it is not that. It is Sustainable Absorption Heat Pump Advancement Laboratory, so it comes like my name. And then we'll talk about something like, I'll go very briefly, background and motivation, research themes, and then because I am in Eisner, so what that means, of course, a little bit of this. Then thermal report, association cooling system, Dr. Hamamoto said about the heat pump system. And then we can also make water from the same system, and also what we can do further, something like that. So this is about the Eisner. It is the International Institute for Carbon Neutral Energy Research, and decarbonization is the one of the key pillars of Kyushu University. And our vision is to create sustainable and environment friendly society. So it should be carbon neutral society, and Japanese government, former Prime Minister Suga already declared by 2050 Japan should be carbon neutral, and also Europe should be like that, and China also declared that by 2060 they will be carbon neutral. So it is very important topics for the world, and our mission is to contribute advancement of low carbon emission, cost effective energy system, and improvement of energy efficiency. And our strategy is low carbon intensity, efficiency increase, and so on and so forth. This is one of the WFEI of Japanese government. It's World Premier Research Center initiatives, but now it is the academy. And Carbon Neutral Energy Research Institute, this is the name in the world, the first, we are the name with the carbon neutral, because we started from 2010, but now it is very popular keyword around the world. And here is the 4 basic research we are working on. One is the advanced materials for association heat pumps. So we want to know the material stability, then kinetics and isotherms of the material. And then here we are working on the component basis things. So if we have very good heat exchanger, how this heat exchanger can improve the system performances, and also system simulation. And Dr. Mutagin even was also the simulation of this system. And then third part is our energy assessment and policy. So we want to see if there is some energy subsidy, how it will hamper or it will improve technological innovation and some other things. And last one is for the fast algae cultivation through negative CO2 emissions. So we want to tap the CO2 from CO2 emitting industry and use that CO2 for algae cultivation. We can use that algae for edible, or we can extract our biofuel from that algae. So this is a very big idea we have. And then our idea also another is to bridge up material science and thermal engineering. Basically, I'm also belong to thermal engineering like Professor Hamamoto, but also people usually work individually, but we want to know material science basics and how we can improve our system through material science development. And also material science people, they don't know what is the need from the thermal engineering people. So we want to bridge up this kind of thing. And by knowing all these things, we can have very good heat pumps, water production, or CO2 neutrality, so on and so forth. And then this is the background things. So by having science-led technology development, we have to know the porous properties of the things, how to we can make the tailor-made our pores. And then our idea is to have the biomasses, which is the waste biomasses like mangrove or waste palm trunk or even waste so it's something like that. And then we can combine this kind of thing and make our heat exchanger which will be functional with many kind of activated carbons or silica gels or MOFs. And then we may use ethanol, carbon dioxide, water, or HCFO type things. So idea is we don't want to use traditional refrigerant like R134A or something like that. Those are environmentally very harmful, but here these are very good for the environment. It's a natural refrigerant. So here this is 0 and CO2 is only 1, but with like 134A, the environmental impact is more than 1,500 times than CO2. And then this is a kind of research network So I like to collaborate with the young people and also like colleagues like my age or even these things. So we have collaboration with many Bangladeshi university and institutions. It is about 10. With India, even it is more. It is 14, and I have many Egyptian students also. So we have collaborative activities with Egypt also. So this is the list where I have at least 3 collaborative research publications. So we have this kind of global networks I have. And then this is the how we work on for the like science-led technological development. We have to know the mathematical modeling. We have to make some engineering equipment so that the equipment should be like optimized or functional, and then we can have some new technology. For example, if we say absorption cooling system, we have to first see the what kind of material we use. We make a simulation, and then we mix our components all together, optimize this thing, and we make our system. And to do this thing, we have to know the force, which is very small scale, nano scale things. Then we have to work about the how the particles should be optimum, and then make our heat exchanger and make the system. So this is a kind of like how these fundamental things work. I am skipping briefly speak these things. So these we have there are many types of like force here. It is microphore or mesophore or many like a broken force. So then we have to the molecular size of the things, we can also tailor made our force. So this is the idea here. And then these are the applications. We can use this for gas sensing, for cooling and desalination, for pollutant removal, energy storage, catalysis. And in our laboratory, we are working on little bit of storage, but working on pollutant removal and absorption heat pump and desalination, and also little bit of sensing. But these 2 part we are not working. But chemical people are working on this thing. And if you see the cooling system, so this will be basically like one evaporator and one condenser, but we have one pair of identical heat exchanger. And ideally, so we also use solar thermal heat or waste heat sources. So when we have absorption here, so if we open this valve, so water vapor evaporates because the pressure is very low, 1 kilopascal, and it absorbed in this bed. And due to absorption phenomena, heat generated in this bed, so we have to cool down the bed. We use cooling water. At the same time, we use hot water to kick out the moisture from the bed, and it is the low temperature heat sources, about 80 degrees centigrade, and the vapor goes to the condenser. It is also water cooled condenser, and from this condenser we can return to the evaporator. And evaporator, because of the vaporization, so we can have the latent heat. So by latent heat, we can give our temperature differences, and that can be used for cooling application. So this is the operational thing, because it's a base cycle. So we need one pair, and also of course we need some preheating, pre-cooling, and that time we close all the valves so that we can preheat and pre-cool these things, so that we have some better performances. And this is the how these things work. But for the time sake, I'm skipping this. And then these are the PTX diagram, and then here is the absorption temperature, is the desorption temperature. So this is our absorption, then preheating, as I mentioned, then desorption and the pre-cooling. And we want to make this thing bigger and bigger so that we have more capacity. So to do this thing, of course, we have to increase the heat source temperature. We can do it. Otherwise, we have to make it with some different like physics. So this is the first absorption cooling system developed in Japan, a single stage, and this was developed when I was the PhD final year student. And then in our laboratories, we develop single stage cycle, 2-stage cycle. We split the temperature of these 2 things so that we can use 50 degree or 60 degree heat sources. And then we also develop 3-stage cycle. So in Japanese, we have the sauna temperature is about 42, 43 degree. We can use this temperature with the 30 degrees summer temperature, so we can get effective cooling from this system. And then these are the performances of like dual mode cycle. We combine these 2 cycles. So in the single stage operation and the 3-stage operation, and this is a dual mode operation cycle. If there is a not very sunny day, the heat source temperature is low, we use this as a 3-stage cycle. Our cooling capacity is around 2 kilowatt. But if it is a sunny day, we can make it about 5 kilowatt cooling capacity with the same machine. So it is operational with the environmental conditions. And then this is also for the COP. COP also varies from 0.2 to 0.45 experimental values. And then these are the summary of many system developed by us: single stage, 2-stage, 3-stage, and the regenerative mode. And last one is the dual mode. So it can be operated from 40 to 95 degrees centigrade. and our COP varies from 0.12 to 0.62. So then briefly about cooling cum desalination, which is very important for Bangladesh. So this is also, we need the optimization. Here you can see we have, instead of one pair of heat exchanger, we have 3 identical heat exchangers here. And we have 2 pressure like evaporators. One is low pressure evaporator and the other is the high pressure evaporator. We feed here seawater, but after some opposite treatment, and then we get high grade cooling from this evaporator. Water vapor goes through this channel to one of the bed, and this in the high pressure evaporator, it also goes to the another bed, and then one bed is working as the desorption bed. It goes to the vapor to the condenser. But here we are not taking this water in the evaporator again, but what we are doing here is we cool down the water and we take the water as a storage of water, and this is as good as distilled water. If you want to drink this one, we need some carbon dioxide or minerals to drink it up. But if you use it pharmaceutically, you can use it as it is, as you receive it. And here the idea is the optimization is there. So our absorption time is a bit longer. So in one of the bed, I can say the low pressure absorption is 7 minutes. Then also 30 seconds also it is continuing. Then it goes for high pressure absorption for 7 minutes, then preheating for 30 seconds, desorption is 7 minutes, and also pre-cooling for 30 seconds. So that means the low pressure absorption, it requires a little bit of longer time, 7.5 minutes, but other is less. That is the optimization we did for this system. And then these are the performances on the result here. This is for our system. The high grade cooling capacity, that is the outlet chilled water temperature at 7 degrees centigrade is found to be 7.1 kilowatt for our system, while the cooling capacity at relatively high temperature at 17 degrees centigrade is about 10.8 kilowatt. And the same system, additional cycle, average water production is about 6.76 meter cube of water per day per tons of silica gel. Here we use silica gel as the adsorbent materials. And then we have for some other application, like in absorption systems, we need a lot of valves here, refrigerant valves here. So we want to eliminate all the valves here. So this is a kind of spool valve here. In the desorption bed, we have the high temperature, so pressure is also higher. So the pressure pushes the spool. The spool will be in this corner, and the vapor from this side through this channel can see the condenser. So from the dissolved vapor goes to the condenser from this side. On the other hand, we have the evaporator here, and then vapor from the evaporator through this channel can see the adsorber. So what happens when the bed are switched to other mode? So our bed pressure increased in this bed. We are using hot water here. So pressure develops here, and then vapor pushes the spool so that the vapor through this channel can see the condenser. On the other hand, evaporator vapor through this channel can see the adsorber. So this is, so we can eliminate our refrigerant valves, like 4 valves. You see the picture here. This is the picture of the spool valve here. These are also patented valve here. So it's very small size. It's taken on one A4 size paper, and we can use our one of the bed here and one of the bed in the left side, and in the this side we connect to the condenser, and here we connect to the evaporator, and it works. And also we want to try some like mop materials these days we are working on, so to make use of composite mops so that we can improve the performance of our systems. And in case of heat exchanger, we develop some hybrid heat exchanger where we have the absorption coated in this with the fins, and then we have loose grains in between the fins, and then heat transfer fluid flows through this channel, and it is optimized kind of performances. So we get better performances than this thing, and it is a patent with the industry with the India. And these are the conclusion of my talk. Absorption is, from my perspective, is one of the promising technologies, and this phenomena can be used not only for cooling but also for cooling cum desalination, cooling cum refrigeration applications, dehumidification, distributed cold storage applications. I did not show, of course, here. And then there are several collaborative projects with industries. We are working on synthesis and characterization of highly porous adsorbent materials for CO2 capture, and Mitsui Chemicals is giving us the funding. And another one is the study of fast CO2 cultivation employing high concentration gas diffusion equipment. Is a Daishin Corporation of Japan. Is another company. And these are the acknowledgement of my students who are here. Like I saw Shoriful Islam is here. He worked for the algae cultivation. And then Rupam is in USA. Rupa should be here. Polash is sick, but he is the co-op general secretary, and unfortunately he cannot attend it due to his sickness. And I saw Kaisar Rocky also here. Onimesh is in Kyushu with me now as the SCS fellow. And Sampad was supposed to come, and Muthiar, I did not see him. and he is also government bureaucrat, also working in Bangladesh government. I saw Shamal also. I also saw Nazli here. So they did PhD with me at some point. And with this note, I want to thank you all for listening.
Thank you, Sensei. Questions, please.
The opportunity to visit Kyushu University several times as a representative of University of Dhaka. As I am a graduate of business, so I don't understand the technical issues. But as you have mentioned, Japan has set the certain target. European Union has mentioned also the target for carbon neutral. But what about the prospects of country like Bangladesh? Because we used to hear that it will not be feasible for us from the cost perspective. Thank you very much.
Yes, right now, of course, in Bangladesh, we don't need to do carbon neutrality. But what we want to do is, or should do is, we should do the like energy efficiency improvement, because this is the country where we have to import also, like our lot of fossil fuels. Even now, the gas also is not very sufficient. So we need innovative technologies so that we can have the same kind of our deliverable things with the less input. So this is one important. But if you see the per capita CO2 emission, Bangladesh is not that high. So we are not in that side. Even in fact, Bangladesh government is trying also. You can bargain more so that from the UN fund you can get more for that new technological development. Another perspective is also through advanced countries like joint implementation also can be done. So we can have the kind of collaborative innovations. And another thing is also, for example, if there is a Japanese like heat pump system or cooling system with the COP of 5, but now they're trying to get the performance of COP of 6. So then if the things there is a little bit of semi-obsolete, we can bring the same thing, because Bangladesh, even the technology is even less like performance is even more energy intensive. So we can replace this thing. So Japan can get some CO2 credit also from that thing. So these are the prospects for the country. Thank you very much for your help and also for the question.
Thank you, Sensei. That ends the session. Turns out we are back on schedule.
Thank you.
Thank you, Professor Shaha, and all the presenters of this session. And we would like to have a coffee break and networking session from this time to 4:30, 30 minutes. So where's the venue? Is it okay? The venue is next door. So please have coffee. Okay, it's 4:30, so I would like to start the next session. And I hope you had a great time talking to each other. Okay, if you can have your seat. Okay, yeah, let's start. Thank you very much.
Thank you very much. Hope you had a wonderful coffee session. So we'll have to get back to our next session. And our first speaker is Masaru Matsumoto Sensei. He's the Associate Professor of Institute of Tropical Agriculture. And his topic is microorganisms associated with arsenic release in the rural villages of Bangladesh. Okay, Sensei.
Assalamualaikum. I am Masaru Matsumoto, an associate professor at the Tropical Agriculture Kyushu University. I am deeply grateful for the opportunity to present today. Although my presentation may be modest, I hope to deliver a presentation that capture everyone's interest. Now, let me begin in my presentation. And arsenic contamination is groundwater occurs when arsenic, a naturally occurring element, reach into the water from surrounding rocks and soil. In Bangladesh, this is a significant issue because many people rely on the groundwater as their primary resource of drinking water. And Bangladesh has faced the severe crisis of arsenic contamination in its groundwater for several decades. It is considered one of the largest mass poisoning in history. Millions of people in Bangladesh are at the risk of exposed to unsafe level of arsenic in their drinking water. Leading to various health programs, including skin regions, cancers, and cardiovascular diseases. Those of you attend this presentation are likely aware, but this slide shows a map depicting the situation of arsenic contaminated water in Bangladesh. The area plotted on the map indicates concentration of arsenic, where blue represents less than 0.5 microgram or less, and red represents 50 milligram or more. As shown in the table on the right, the WHO standard for arsenic concentration is 10 micrograms, but Bangladesh's and India's water quality demonstrates significantly higher level of arsenic contamination compared to WHO standard level. The provided contents appear to refer to the geographical context and the transportation mechanisms of sediments containing arsenic from the Hirayamas to the Bengal Delta. Let's break it down. This kindly refers to the geographical factors that contribute to arsenic contamination in certain regions. Arsenic contamination often occurs naturally in groundwater due to the presence of arsenic-rich minerals in the Earth's crust. Understanding the geographical background helps in identifying areas prone to arsenic contamination and devising a strategy to mitigate its impact. This involves the environment of sediments containing arsenic. Sediment in river system can carry arsenic either at dissolved form or as particles attached to sediment grind. Understanding how these sediments move is critical for predicting the distribution of arsenic contaminated area and the risk to human health and the environment. The Hirayamas are a significant geographical feature in South Asia, known for their vast mountain ranges. The Bengal Delta, on the other hand, is a densely populated region formed by the sediment deposition of major rivers like the Ganges and Brahmaputra. Sediments organizing from the Hirayamas and transported by these rivers to the Bengal Delta, carrying with them various minerals, including arsenic. Arsenic is a naturally occurring element found in the Earth crust. It can be released into the environmental through natural process, such as volcanic activity, weathering of rock, and erosion. Additionally, human activities such as mining, industrial processes, and the use of arsenic-containing pesticides can contribute to the release of arsenic into the environment. Arsenic can exist in various forms, including inorganizing and organic compounds. Arsenic is highly toxic to human and organisms. Its toxicity depends on several factors, including its chemical form, concentration, duration of exposure, and route of exposure, such as ingestion, inhalation, or skin contact. Chronic exposure to low level of arsenic in drinking water is a significant concern, as it can lead to various health problems, including skin lesion, cancer, cardiovascular diseases, and nucleological effect. Accurate arsenic poisoning can also occur from the high dose exposure, leading to symptoms such as vomiting, abdominal pain, diarrhea, and severe case, coma, and death. This slide shows a genetical schematic diagram depending the conversion of arsenic compound and the environment of soil microorganisms. Regarding the relationship between the arsenic acid and arsenic acid, arsenite acid, it is known that soil microorganisms are able to oxidize arsenic acid and reduce arsenic acid by planting a role in releasing arsenic microorganisms. Previous research related to these experiments will be introduced at the case of Bangladesh and Vietnam. It is suggested that the rise of the density of the underground water arsenic is caused by strong reduction according to the activation of microorganisms under the oxidation environment of the soil in Bangladesh. Second is in case of Vietnam, the number of bacteria is microorganisms by which the most important role play material circulation in the soil and in water was measured because the arsenic was included in the underground water of the Mekong River Valley voluminously in the relation to an environmental factor of the material change and piling filling up soil was examined. Yes, Shamim and Kurosawa inferred that there are microbial correlation between high concentration ammonium ion and arsenic releasing by soil reductive condition. Moreover, the component of chemical fertilizer, nitrogen enhance microbial activity. Specifically, there are no precedents for studies targeting peat soil. Therefore, as the arsenic release theory, chemical nitrogen fertilizer effect on the microbial activity will be explained. Nitrogen fertilizer changes the groundwater reduction condition, which influence to release arsenic in groundwater. Most of the groundwater samples containing high ammonium nitrogen in Bangladesh. The increasing of ammonium nitrogen indicates high microbe in ground aquifer, where microbes consume oxygen and change to reduction condition, and arsenic is released in groundwater. This slide shows the soil pollution and function of soil microorganisms. This is a two section. One is ammonia pollution. Ammonia is a common pollutant in the environment, particularly in agricultural setting, where it is often found in fertilizer, animal manure, and wastewater. High levels of ammonia in soil can result from excessive fertilizer application, intensive livestock farming, or import per waste management practice. Ammonia pollution can have a detrimental effect on soil quality, plant health, and groundwater quality if it is leached into water bodies. Second, provided sentence suggests that there is a specific focus on the relationship between soil pollution, particularly ammonia pollution, and the functions of soil microorganisms. Soil microorganisms, especially creating a certain group of bacteria and fungi, critical role in the nitrogen cycle and can metabolize ammonia through processes such as nitrification and denitrification. This slide shows the study area and soil sample collection. Sorry. This is also the sediment and fertilizer sampling and preservation. In this experiment, we carried out manually boring, such kind of this procedure. Yeah. The soil used in the environmental consisted of soil sample taken from the upper layer of the soil and peat layer, approximately 10-meter deep. Regarding in this, the isolation method of soil microorganisms, one is initially 5 grams of soil were mixed with 45 milliliters of distilled water to create a suspension, and dilution of 10 whole and 100 whole were prepared. Second, subsequently, 5 milliliters of each dilution were added to 45 milliliters of isolation medium for nitrogen utilizing microorganisms. Third, the mixture was cultured by shaking for 1 month. And then this slide indicate the procedure for the extraction of bacteria, PCR reaction, and DNA sequence for identification. Though genetic diagnostics, we are able to identify two species of nitrogen bacteria and two species of ammonia oxidizing bacteria. One, denitrification bacteria. These kind of denitrification bacteria includes Toribacterius dentrificus, Micrococcus dentrificus, and Paracoccus denitrification and Pseudomonas that are land in rather well cultivated. Denitrification bacteria are another group of bacteria involved in the nitrogen cycle, but they carry out denitrification, a process where nitrate is converted to nitrogen gas or nitrate oxide under anaerobic condition. Characteristic of determination bacteria may include possession of enzymes like nitrate reducase, nitrogen reducase, and nitrogen oxidase reducase, which categorize the reduction of nitric to nitrogen gas. Adaptation to anaerobic environments as denitrification typically occurs in oxygen-dependent conditions such as waterlogged soils or sediments. Various general bacteria capable of denitrification, including Pseudomonas, Paracoccus, and Bacillus. Second ammoniting oxidizing bacteria. Nitrifying bacteria are chemoautotrophic or chemolithotrophic, depending on the genera. For example, Nitrosomonas, Nitrococcus, Nitrobacter, and Nitrococcus bacteria that grew in the consuming inorganic nitrogen components. This kind of bacteria, a group of bacteria that play a critical role in the nitrogen cycling by oxidizing ammonia or nitrate as part of the process of nitrogen. All these species are found to be anaerobic and heterotrophic bacteria. These bacteria species were commonly isolated from the both surface soil and peat soil with high detection frequencies in terms of number and density. While we conducted identification of other microorganisms as well, many belonged to the category of organic matter degrading microorganisms, which we could not present in this study. We aim to elucidate these results in the future resources. Finally, it can be conducted that chemical nitrogen fertilizer, when correlated to downward and act on peat sediment, then change the physicochemical properties of peat and influence on microbial activity. Thus, arsenic release occurred in the groundwater. One, application of chemical fertilizer on peat sediment. Second, soil interaction. Third, ammonium nitrogen conversion. Fourth, peat decomposition. Five, release of arsenic. Six, increase mobility. Seven, contaminated pathway. This flowchart illustrated the sequence step in the process by which arsenic is released from peat sediment into the soil solution, specifically that to the application of chemical fertilizer. It is highlighted the role of enhanced microbial activity and decomposition process in the peat sediment, leading to the mobilization of arsenic. Understanding this mechanism is critical for managing arsenic contamination in peatland and mitigating its environmental impact. Finally, this is a conclusion of this presentation. I will introduce the final phase. The relationship between these bacteria and the arsenic reducing and arsenide oxidizing bacteria would investigate to the future research. Thank you for your attention. Sorry, I have a little bit.
If anybody has any question.
Catch a cold.
Thank you, Sensei, for your nice presentation. So this is a part of natural process because bacteria are there and the using of fertilizers. So these fertilizers, I think, used by some other countries, and these bacteria also present in other countries. So why the arsenic is very high in Bangladesh, India?
He's this kind of research, and instead of me, he will answer against this question.
Actually, in Bangladesh, the peat sediment, during my PhD research, I did some of part of this research. The peat sediment contain the highest arsenic concentrations. So when the presence of nitrogens and the reducing environment in the ground aquifer, that cases the rate of arsenic leaching increases. But in case of the other area, we also did some research in other area where no arsenic, that cases there is no peat layer. So some cases there is peat layer, but many cases there is no peat layer. But due to the peat layer, blackish peat layer, that contain highest arsenic contaminations. That is around highest we found around 100 milligram per kg arsenic in the peat sediment. But in case of normal soil, less than around 1 ppm to 2 ppm arsenic. So the main cause of the peat sediment in some of aquifer.
What percentage of our soil is peat sediment in Bangladesh?
No, normally in the top part, no peat sediment, but some cases the bottom layer around in my studied area, we found 10-meter depth, 9 to 10 meter depth. Some cases, some of the soil is peaty clay.
Is there any filter for filter?
Oh, there are many filters in Bangladesh. And normally some of the zirconium filter, we say, some of the activated alumina, granular ferric hydroxide. Normally there is no such a filter, but if we design the community type filter, that cases we put this type of reagent, activated alumina, granular ferric hydroxide, zirconium, this type of materials remove arsenic up to 95%.
It is costly.
Environmentally, this is the sludge management is little difficult here.
Thank you.
Thank you. Instead of my
Arigato gozaimasu, sensei.
You sensei. He is my sensei.
Thank you, sir, for the insightful information. Okay, our next speaker is Kazuo Asahiro sensei. He's the professor of Faculty of Design. His topic is Techno Deforestation and Society.
ここが反応しなくなりました。ここが反応しなくなりました。
スライドが動かない。重いか。
ちょっと待ってください。こっち切ります。
うん。ズームと動かしてるから。はい、ありがとうございます。Thank you very much. Hello, everyone. It is an honor for me to have this opportunity today. I'm belonging to Faculty of Design. The concept of design means to fuse design and art with science and technology. So our faculty focuses on designing for people, society, and nature. Today, I'd like to present the topics technical deforestation and society. Today's topics consist of three: the background to the research, the status of deforestation, and studies on homestead gardens. This series of deforestation studies was carried out by Professor Masakazu Tani, the former dean of the Faculty of Design. He retired last March. Professor Tani has received a series of JSPS grants without interruption since 2012 as project leader. And the general achievement was published in 2018 by Springer. This research was carried out by a collaborative team: Dr. Sakamoto of University of Tokyo, Dr. Moriyama of Nagasaki University, Dr. Sato Noriko of the Faculty of Agriculture, Kyushu University. On the Bangladesh side, at the beginning by Dr. Zulfikar Rahman, Dr. Zofar Morsuddin. Throughout the project, we had the support of Professor Abir Rahman of BSMR Agriculture University and Dr. Asik Ura of BAU, now Kyushu University, and to Delwar Hossain, our local collaborator, for always working with us. So now on to the first topic. First, I note that half of this slide was made by Dr. Asik Ura. This data is the work of Dr. Tani and team. As a member, I am doing the presentation on their behalf today. So the research had started around 2009. The first research question was, who had been devastated in the Teknaf Wildlife Sanctuary forest? But there was no household statistics and no map at the time. So from 2012, baseline survey was started to confirm all household number and location from north to south in Teknaf Peninsula. And we confirmed 147 village and 57,404 household. Then 10% sample of household was taken. More detailed questionnaire survey was conducted to 5,769 households. As a result, 45% of households were directly dependent on the forest. This is an analysis of satellite image showing the change in forest cover between 1989 and center is and 2015. The left image is 89 and the center is 2015. The right image shows the area of deforestation. There has been 46% decrease in forest cover and 49 increase in shrub covers. The right image shows the distribution of conserved and degraded forest, which is varying from area to area. This graph shows land use conversion pattern. Left inside Teknaf Wildlife Sanctuary and right
is outside. Left figure, it is so narrow. This dark green is forest. Most of the forest has been converted to rainforest and bush, and could confirm the rotation between bush and rainforest. Right figure around TWS could find the same pattern, but light green shows a lot of afforestation area could confirm. We assume that this is a type of homestead gardening. I mentioned that 45% of households are dependent on the forest. It is engaged in deforestation drivers as 37% is harvesting fuelwood, 11% is encroachment, and 9% was agriculture. Specifically, cooking with firewood, using poles to grow crops, and clearing forest for homestead garden. There used to be a Rohingya camp in this area. However, from 2017, there has been a large influx of refugees. Refugees were accommodated in large camps, and the forest and local homestead garden were converted into campsite. These are the before and after satellite images of the largest campsite in the Ukiah area. In this situation, the government provided LP gas to the community. Our research looked at the impact of LP gas on the conservation of the forest and the rate of adoption of LP gas in the community. As a result, more than half of the households started using LP gas. It was found that around the hotspot of LP gas users, there was less deforestation and a higher rate of reforestation. But I have the impression that some of the LP gas users have stopped using LP gas and have gone back to using firewood in recent years. The rising price of LP gas is the reason for this. It is not known whether the widespread use of LP gas will lead to an improvement in forest conservation yet. So now on to the second topic, homestead garden studies. Despite the forest devastation in Teknaf Wildlife Sanctuary, homestead garden establishment is very well. Homestead garden contribution to livelihood is extremely high. Knowing the relationship between the structure of the garden in daily life is important for local security. The research objectives were to develop a typology study of garden and to secure the ecosystem service. So I'm going to present some classification and their characteristics of the owner perception regarding the value of the garden and its future perspective too. I extracted 301 homestead from the base data. The condition for the extraction were 50 years or more of residence in the village, so on. First, gardens were classified by area differences. Then cluster analysis was carried out using garden tree species of each class. The ranking of value recognition was also analyzed for each class. The data was used with 117 gardens that could be confirmed on field survey in 2022 to 2023, last year. The image on the right show the average year of life of household on the village map. Red zone indicate village with average over 80 years. I'm curious about garden design and the area history, but I haven't done anything on these topics yet. This table shows the difference in area of each union of Teknaf. Town area has 53.8% garden, less than 200 square meter. Wycombe has more than 600 square meter of garden with 38%. But there seems to be 200 to 400 square meter garden in the other 4 unions, Teknaf Sadar, Baharachara, Sabrang, and Nila. This graph shows the histogram of the garden area. It was able to confirm 4 peak value, 120, 240, 320, and 440. I assume that there will be a type of garden designed according to each categories of area. In the garden survey, we confirmed 84 tree species, and this table shows species frequency that has done cluster analysis to each of area class. We could confirm main planted species to all class, but there was a difference of tree planting design. Particularly, could be divided to the Shupari-oriented garden and the other fruits tree garden. Ranking of perceived value. Most garden shows first is earning cash crops and timber. Second was self-consumption of fruits and vegetables. However, at around 440 square meter of garden area, the demand for self-consumption seems to be higher than the demand for cash for garden use. In terms of envision the design of future garden, about 70% choose continue way of use as same as now. However, about 30% consider reduce the tree and make open space for other use. It means that there is a trend of the decreasing garden trees. There seems to be more demand for sale and self-consumption on the larger garden property. In this garden survey, we have carried out spatial data collection using the LiDAR scanner to take 3D point cloud data and 360-degree photographs. Now I'm in the process of modeling each type of homestead garden from this data set. Now I'll show you several gardens that confirms the cause of tree decline. In this garden, various species of trees were planted in grandfather's generation, but the present head of household has cut down these trees and converted them into shupari to get more cash. Mango and narikelu have cash value, but the younger generation seems to be more interested in shupari. In this garden, many trees have been cut down and building extended for rent. Homestead garden tree converted to urban use. This garden owner claimed irrigation of shupari sapling has failed to grow them. I doubt that excessive pumping of groundwater has increased the salinity of the well. In 1991, this garden experienced a cyclone. There was a tall coconut tree and 400 shupari. They were all destroyed. Global warming is a critical risk for the conservation of the garden trees for our future. The current conclusion so far suggests that deforestation in Teknaf occurred due to local livelihood and refugee influx. There has been a confirmation of the reforestation trend around the gas exploitation areas. However, we still have concerns. Gardens which have supported livelihood in the face of poverty are in decline. This is due to population growth, refugee migration, and gradual urbanization. Garden conservation measures are needed, but I'd like to continue modeling the type of garden each area class from the perspective of garden design. Thanks a lot for attention. Yes.
Now, is the time for questions or to have comments? No question? No comment? Yes.
Is it possible to accommodate electric cooking in those areas? So if it goes to the electric cooking system, then it may help. deforestation or something like this?
Yeah, I think so. That is one of the reason. But not only the cooking, but agricultural use and the other usage also having.
Is it possible to promote solar PV system for electric cooking in those areas?
But Teknaf is a very low income area, so people have much cash resources. So and now population is growing with refugee camp status. So maybe those area is the most difficult.
Is it possible to get
So
some
we need to
grant?
think the both side, the supply those high tech, not high tech, but those facility. But on the other hand, those woodland using for charcoal or something, it's a very sustainable way, naturally, I think. Of course, national woodland deforestation is not good, but there will be the solution to coexist with local livelihood.
Actually, Teknaf area, the annual solar radiation, the highest, I think, in Bangladesh. And if you go to the Teknaf, just Nila, if you pass, then you can find a very big and very large solar power plant. And I had opportunity to visit that solar plant. But the main problem is the solar energy and electricity, mostly they are putting to the national grid, and Chittagong and other big cities they are using. Not even there is a very big solar plant, but there is a huge electricity shortage. And another big challenge is even LP gas and electricity, the supply is very limited because the communication from Dhaka is very far. And another is they are getting firewood and other materials very easily from the forest area. Even we talked why you are not emphasizing on your homestead garden, because for fruit tree they are trying to plant more fruit tree, but for fuelwood they are not interested because they are getting very well. Another point, since I already mentioned that some area which is very close to the forest area, that area is more the situation is different from the union that is far from the forest area. So actually that area is very complex. And after 2017, when Rohingya influx was huge, then the situation also became another complexity. So we had been working for a long time, since 2010, but the situation before Rohingya and after Rohingya and other issues is very complex. So he addresses many of the issues, and I think we need to think of it for our existence, because Teknaf Wildlife Sanctuary is very important for Bangladesh. White elephant and other biodiversity, in terms of biodiversity, we need to conserve it. Thank you.
Thank you.
Every census, big support.
Thank you very much, Sensei. If you, I think we can go for the next speaker. Our next speaker is Associate Professor Kim Shamacher. He is from Institute for Asian and Oceanian Studies. His talking title is The Role of ESG, Investing in Scaling Sustainable Development in Asia. Please.
Hello, I'm the last. Hopefully, it's still of interest to everyone. My name is Kim Shumarka. No, I'm not from Bangladesh. A lot of people talked in Bangla to me, and I could unfortunately not respond. So, yeah, but I do get. I'm originally from Luxembourg. I do have also Indian origins. So 3/4 Indian, so that is why. But yeah, it is a pleasure to be here, and I will talk a little bit about my field, ESG investing and sustainable finance. And having been yesterday, that is just a small anecdote that I thought I should just mention. I just on the flight to here, I was sitting next to someone from the Japanese Development Agency, and it also, the topic was climate finance and development finance. So it is a very relevant topic for Bangladesh and for developing countries. So I do think it is quite important. But today I will just give a broad introduction and some of the research that I did, which might be helpful. So I will talk just a short introduction, very brief, very general, and then I will talk a bit about sustainable finance and ESG concepts. What are we talking about? And then a case study that I performed was venture capital sector in Japan. And since we're talking about small and medium enterprises, that is also a topic that can be very relevant in a broader Asian context, because the same struggles I found that affect even still small businesses in Japan, they also affect other small businesses throughout Asia. So an introduction. Of course, we're talking about the Sustainable Development Goals. Everyone is, at least in this room, I suppose, is more or less aware of the 17 SDGs. So I will not dwell too much on those. But what a lot of people do not know, we need a lot of money. I think everyone knows we need a lot of money to realize those SDGs. But the question is, where do we get that money from? Who is willing to open their pockets to finance all these projects? And that comes down to investors. And we have different levels. We have different types of investors. We have those who are, like, for example, donations, charities. And then we have those who have, for example, seek a social impact. And then we have those just conventional investors who seek hard, large returns on their investments. And at the end of the day, also what a lot of people do ignore is, at the end of the day, it's the people. Because a lot of investors are just regular people like you and me. We do that via our deposits at a bank, or we do that via our small investments here and there, or we do that via our loans that we take on, our debt that we take on, or we do it via, for example, in Japan, a lot of when you pay into a pension, and that money is then managed by the government on behalf of the people, and it is often done via funds. And these funds, in order, they also want to generate returns, they reinvest that money, both domestically and internationally. So if we see on the left side, we see people. So at the end, we basically contribute a lot of the money that is then being used by different organizations and institutions for investments to basically generate returns. But how that money is invested, that is very, very important. And I think here in Bangladesh, everyone is aware of UNUS and the Grameen and the microfinance. And now let's just imagine scaling that. Is it even scalable? Can we implement sustainability into much larger, broad, sustainable, infrastructure projects or large investment portfolios? So that is sort of the research that I do, because we need to somehow get to fulfilling the SDGs. So sustainable finance and ESG concepts. So this is just a little bit of numbers. And one of the things I do not want to go too much into detail is just it has been growing exponentially. That is the point that I want to make. So sustainable funds and assets, that can be anything from bonds to real estate to anything, that can all be counted, and it has been growing exponentially. But as we see here, it's mostly been in Europe and the United States, and Asia is still falling behind. And you now see sustainable funds, and you wonder what exactly makes a fund sustainable, and that is what I will explain a little bit more. So a fund can be sustainable by the type of assets that they invest in. For example, health, climate change mitigation, agri-food systems, and as was mentioned previously, ecosystems, biodiversity, telecommunication infrastructure. So a lot of types of assets can be qualified as contributing to the SDGs, contributing to sustainability. So if you set up a fund and you go to different investors and you ask them, please give me money because I want to invest in certain types of projects, if it includes health, for example, you're pretty much on the safe side, and it's immediately considered sustainable, more or less. And this is not so important in the sense of what measures have been taken, but rather who has been taking them. And as if we see, Bangladesh has been taking some of those steps in order to promote sustainable finance. For example, sustainability disclosure, that means listed companies, large companies in Bangladesh need to publish certain minimum information about their sustainability impacts. And then also sector-specific measures, for example, large infrastructure projects and products also sometimes like, yeah, certain pollutants also need to be reduced, things like that. And it just goes to show a lot of countries are now trying to promote sustainable finance. Japan as well. It's one of the few countries that has a national strategy or framework for sustainable finance. And this map basically just shows some of the countries that have taken action. Bangladesh, for example, green products and initiatives is one of the policies. And it goes to show there's a lot of awareness around it, this topic. But one of the things is always in this research, what are we actually talking about? And I mentioned it already a bit earlier. So you have the spectrum of social and sustainability investing. So you have philanthropy, charities. One that I always mention is like the Bill and Melinda Gates Foundation. They are considered a charity and they usually don't expect a financial return. But then you have social impact investing, usually below market returns. So they usually accept that the return on investment is a bit lower than would be in a conventional market. That is usually development banks, foreign development agencies, things like that. And then we have sustainable and responsible investing. That is regular investors. They still expect a return, but they want to invest as sustainable as possible. So what that means is they try to still consider if all things are equal, they will go for the more sustainable option if possible. And then just conventional financing. So sustainable and responsible investing, what falls into that, I will explain that a bit more. So you have ESG, and that is the term, and it just stands for environmental, social, and governance. And it includes different metrics, renewable energy, greenhouse gas emissions, and then for social health and safety, very important during COVID. And for governance, ethical standards, one of the big ones is corruption. For example, bribes or things like that, that is very important. I won't go too much. These are just in a bit more detail, but the previous slide basically explained it. It's just metrics to look at environmental, social, and governance factors. In Bangladesh, for example, water would be one of the big E metrics. But one of the things is what I also look a lot into is investment strategies. And that is where we go. And that is also where everyone can try to adapt to global investors. So best in class is, let's say, for example, you have a portfolio of 100 companies, and then you just want to know which of those companies is the most resource efficient in terms of water. And then if you have, let's say, 10 companies that do similar activities and you want best in class, then you can say, I just want the best of those 10 companies in my portfolio. And that is best in class. It's as easy as that. You just choose the best. You can say the 5 best, the 10 best, or just 1 best. Then you have engagement and voting. That is where you use your shares that you have to try to communicate with the company and say, please improve your sustainability footprint. You can do that via using your shares at annual shareholder meetings, things like that. So it's just engaging, trying to engage with the company via the power that the shares give you. ESG integration is looking at the metrics, for example, water stress, and then you see what company is doing well, and then you can decide sometimes like, yeah, we go for the better one. That doesn't mean that we use only the best, but we try to still take it into consideration. Exclusions is the easiest. Exclusions is what most investors use because you can just exclude certain sectors straight up. For example, weapons is one of the big ones, gambling, alcohol. You just exclude entire sectors and you just say, we will not invest in those companies. Whatever, if they, or it's like mixed companies, if they get a certain type of return from those activities, we don't want to invest. A good example is, for example, Islamic finance, where you have certain things that are already automatically excluded. So that would be a good example of funds that use exclusion policies. Inclusions is the exact opposite. You include certain types, for example, renewable energy needs to be included, things like that. Impact investing is a very intense form of sustainable finance because you want concrete results. With the other ones, like ESG investing, it's good if it has a positive outcome, but if it doesn't work, it also is still fine. With impact investing, you want the positive outcome, and often those investors expect lower returns. They say, for real documentation, for real impact, we accept slightly lower returns. And then norms is like human rights. You don't violate, for example, international child trafficking laws, things like that. And sustainability theme, for example, education can be one theme. So that is the type of investing. I will not go too much into these slides in the interest of time. How much time do I have left? Ten minutes. Okay, wow. I'm pretty efficient today. Wow. Okay. Yeah. So, and what this slide basically just means is, when do you carry out your analysis? So if you're a fund manager, you need to decide, I get all this bunch of money, where do I invest it? How can I be as sustainable as possible? When do I need to do my analysis? So best in class, you do the analysis afterwards. You look at data that is there, and then you see, okay, this is the best company. So you act afterwards. But for exclusions, you don't even need to look at the company. You just look at the sector and you exclude it already beforehand. So that is what we say pre-analysis. So in one, you actually need to do an analysis yourself. With the others, you can basically just program an algorithm that says, whenever there's like gambling, just exclude it immediately. So that would be the difference between those two. And why do we do it? At the end, it's also money. And there's one paper that is very referenced and highly cited, but there's also now new papers that challenge it a little bit, but it was one of the main foundations for sustainable finance in general. Is they did a meta study, and they found that through all the papers that looked at, does integration, so ESG, be it environmental, social, or so, into your company or into your investment strategy, does it pay off? And apparently it generates more returns than if you just go a conventional route. And one of the explanations that the authors give is that because companies that already follow those things, they're usually better managed, they have less drama, they have less conflicts, they have less, for example, less conflict, just less controversies, things like that. And that leads to better returns ultimately. So in theory, if we follow this academic study, and also some of the studies that have confirmed it, but recently also some studies call it a bit into question, technically investing sustainably also generates better financial returns. And that is the main premise. And one of the studies that we did was looking at the venture capital sector in Japan, because if we go with this premise that if you invest sustainably, if you respect the environment, if you are very socially conscious when you do, for example, in terms of gender equality or in terms of health benefits, things like that, you basically perform better than other companies who are not as sustainable. So, but is there an awareness around that? And because investors are very interested in sustainably run companies, they sometimes are even willing to invest preferably into those companies than into conventional companies. So it would technically pay off, but is there a lot of awareness around very young companies, startups, small, medium enterprises in Japan? And so we did a study together with our university, with the Tokyo Institute of Technology and Stanford, to look at ESG in Japan, especially in the startup investment and the venture capital sectors. Why did we do that? Because small companies are usually the ones that have the least awareness, and it is also the most transferable onto Asia, because a lot of companies are just starting their journey now. A lot of countries have a lot of young people, entrepreneurs, trying to do their own businesses, so it's very relevant. And we've seen the global venture capital sector has been growing, so there's a lot of money floating around that technically can be used. And even recently in Asia, also in Bangladesh and India, South Asia, there's a lot of money flowing into small investment funds for small startups. And in Europe, so I talked about the investment strategies. And here we see already a lot of investors, like be it venture capitalists or so, they already consider like these ESG or sustainability criteria when they make investment decisions. So who to give money to. And here we saw what I explained earlier, like negative screening is exclusions. So how do they usually do it in the sense they just exclude certain sectors. So if you're a startup in a certain sector, you're already excluded from receiving money. So sometimes, therefore, it pays off to be a company in a certain sector that is considered sustainable. For example, water purification could be one of those. So then you're not in the negative screening area, and you're likely to get more money from investors. So the methodology was we looked at 43 startups, and 39 of them were investee companies of an incubator in Japan. And and 4 of them received additional support. But I will not go too much into that. And a total of 37 firms across different have responded to our questionnaire. So not every company responded. And we divided them into different sectors. I'm not this materiality map, but so 37 of those did actually respond at the end of the day. So we sent out a questionnaire to 43 of them, 37 of them responded. I will not go too much into the methodology, but the thing is, the challenges that startups basically face, and I think also a lot of small companies in Asia and also in Bangladesh, is capacity. So how much skills do you have? Can you find the right people with the right skills in sufficient quantity to basically scale your business? Then the strategy is does sustainability actually add value or scale? And that is this dilemma that we found is there's this dilemma that a lot of businesses also in Bangladesh face is we need to become big pretty quick, and we need to have like the necessary resources. Does that allow us to still be sustainable at the same time? Because sometimes generating revenue is more important, at least in the short term, than being fully sustainable. And that is the question that we explored. And the results were, so these are the industries. So IT, hardware, machinery, goods, aerospace, solar technology, and the largest was in the health division. So a lot of those that are already compliant with sustainability or ESG because they're just promoting health. And here we see a bit the awareness. So most of them were aware of the SDGs. And I think nowadays, even some here, they have the SDG pin. So I think that is a lot of awareness. But there was not so much on other concepts that are important for renewable investment. And does your business have sustainability, ESG related policies in place? Surprisingly, even in Japan, a lot of them said no. So even all this awareness around the SDGs does not necessarily translate into sustainable management. Then are ESG criteria, so ESG sustainability criteria, considered in your business decision process? No. And that was one of the most interesting categories. We thought there was more awareness around it because everyone always thinks Japan very sustainable. Everyone has the SDG pin. A lot of sustainability is mentioned in the marketing material. But when it really comes down to businesses making hard business decisions, SDGs and sustainability are not that prevalent. And most of them, when they did that, why did you even do that? It was because investors asked them, or like positive reputation. That was one of the most important, and then sometimes ethics and social responsibility. So those were, and then on the other side, why did you not do it? Low investment priority. We don't know if it makes money. We need to get funds as quickly as possible to survive. So we cannot really consider sustainability at this moment in time. And then also limited resource or expertise. We are not sustainability experts. We are engineers, or we are pharmaceutical experts. Why do we need to deal with SDGs or sustainability? That was one of the big responses. And then the biggest challenges was fundraising. Where do we get money? And I think that is very, in all of Asia, a very prominent topic for a lot of those entrepreneurs, fundraising. And that is where we say it pays off to be more aware of the SDGs or sustainability when you make your decisions, because investors are looking for those opportunities right now. So it might be easier to get money. And in the interest of time, I think I'm almost out. I basically already made my conclusions. A lot of them are struggling, and it pays to be aware of the SDGs and also integrating it actively. So that was one of the key findings. And I think that is a very also relevant conclusion for Bangladesh and for Asia, especially for small and medium enterprises. So thank you very much for your time.
Thank you, Prof, for such an efficient and informative presentation. Any question, please?
I think all questions have been answered, I guess.
The slide showed that education has very least priority at some point. I saw in the beginning slides.
Oh, this one. Reasons for not?
The very, very early slide.
This one, or
no. Much earlier.
Much earlier.
Yes.
Oh, this one maybe, or
no. Yes.
Oh,
yes. So could you explain again why, like, for example, health and climate change mitigation is good, but then of course education, transportation is not that good? Is there any reason behind this or something?
Share of sustainable funds invested. So one of the things is health. It just generates the most returns. That is the easiest thing. It's easy to patent, and a lot of money just goes into those sectors like biopharmaceuticals, things like that, because you can label it as sustainable immediately. It's very easy, very evident, self-evident, and also it generates a lot of money. Education, it's much harder to generate money in education. So a lot of them stay away from that, and investors just pour a lot of money into health because it generates a lot of money. And climate change mitigation is mostly energy. So renewable energy infrastructure. So that is why the money goes there. So this is basically like the share of sustainable funds assets, and it's primarily a financial rationale.
But I think education part or transportation, it is directly like this. But if we consider like indirect benefit for the nation, it will be huge, something like that.
So I think that is something that needs to be considered more. But currently, investors, or at least how this is by UNCTAD, so by the United Nations, how they considered it, they labeled it as this. So I think that is an important discussion to be had. Like, what are the direct and indirect benefits? Thank you very much.
Anyone else? Okay, I'm not sure if I'm allowed to ask, but I need to ask something. I mean, what's your role in this? I mean, just to study, or do you also bridge the investors with the entrepreneurs or something like that? Because I need some money in that case.
I do. I do also sometimes advise, or I work with like international development agencies together, because a lot of them also are just on their journey to identify, as was mentioned now, education sometimes is not at the forefront or different aspects are not at the forefront, because it's very delicate, because in a lot of investors' mind, it's also still sustainability doesn't make money. So why should we do that? But now there's more and more evidence that well-run and integration of sustainability actually performs also better financially, because it's less exposed to risk. So yeah, I do the research, but I also do sometimes very applied research, that I work with the actual stakeholders, because they are the ones who need to make the decisions. And sometimes a fund manager who has been dealing his or her entire life with just investing conventionally, and now is suddenly be giving the instructions, please invest sustainably, they do not really know what that means. So there needs to be a lot of capacity building, a lot of information of what can actually be considered sustainable, and how can we find that balance between sustainability and finance. Yeah, so I do work also with actual stakeholders, like in this case, venture capital space, or for example, development agencies, things like that. Yeah.
Okay, thank you, Prof.
Yeah.
Okay, thanks a lot. Okay, now we'll jump to closing remarks. First, we'd like to hear from Dr. Shikdar M. Asaduzzaman. He's the president of Kyushu University Alumni Association, Bangladesh.
Mic is open or closed? Distinguished guest from Kyushu University and the respected guest from Bangladesh and my Kyushu University alumni here in Bangladesh. Good afternoon, everybody. Actually, this is a very wonderful moment for KYUDAI alumni in Bangladesh today. Kyushu University Alumni Association was established aiming to make bridging among the alumni and to the Kyushu University's activities, and also to the societies that can help building our nation in cooperation with KYUDAI and to other Japanese bodies. However, we are very enthusiastic today, the KYUDAI alumni, that we could have such an event in Dhaka. We are expecting that Bangladesh would be a developed country in 2041. By this time, we have many challenges. We have to achieve the Sustainable Development Goal. I think we have to obtain many cutting-edge research and technology achievement, and Kyushu University could be very helpful for us for achieving. Especially, we would be the middle of these activities, the alumni who are in Bangladesh especially. We are very thankful in this way that we could have the chance. I like to express gratitude to my fellows, the Kyushu University alumni here, who are very enthusiastic to have this kind of activities with Kyushu University. And on the way, we like to pave the development goal of Bangladesh to reach in 2041 as a developed country. I am very thankful to the Kyushu University Alumni Association in Bangladesh. Our people warmly engaged in every activities, and simultaneously, I should have these comments that in between, we have two advisors, and among them, Professor Bidyut Baran Saha is present here. Actually, he is working as the key person to have this kind of activities with Kyushu University and Co-op. I like to have a big hand for him. I am very thankful to the Kyushu University Authority to have the chance for us for selecting Bangladesh to have KYUDAI program in Dhaka this year. Thank you, everybody. Best luck for everyone.
Thank you, sir. Finally, we'd like to hear a few words from the Vice President of Kyushu University, Shimizu Sensei.
Hello, everybody again. So first of all, thank you very much for being with us here all the afternoon today. Special thanks to Asado-san, President of the Co-op, and Shaha Sensei for organizing this forum together with us, and also to Dr. Mutakin-san for being an MC today to run a very good program. And also, I'd like to express my special thanks to Ueda-kun and Satomura-san for all the preparation from the very beginning, and also the technical help for the online streaming as well. So I believe that many of you understand what the KYUDAI now means. But for those who may not understand what the KYUDAI is that this is an acronym, short name for the Kyushu University in Japanese. So what the KYUDAI now means is that we would like to show what we are doing now to the alumni people in Bangladesh this time. So I do hope that you enjoy the program and presentation today. But one thing which is different from the regular forum is that the presentation covers all different variety of the specialties. Usually we focus in one topics, right? So like agriculture or engineering or something like that. But the presenters today, they specialize in, the education, engineering, agriculture, design, and economics, and something like that. So the purpose of this, covering a variety of field, is that we want to bridge the field, variety of field. We don't, we really want to people to be united beyond the specialties, and we'd like to have a collaboration not only between faculty to faculty, but between the university and the university. I strongly believe that we can have some reactions, among the different fields. So that's the special purpose of this KYUDAI Now. So lastly, our staff, Ueda-kun and Satomura-san, will send you the questionnaire request, maybe probably soon. So I really appreciate in advance your precious feedback so that we can have a better forum next year. So see you next year again here. Thank you very much.
Okay, thank you for the closing remarks. Okay, some housekeeping. The dinner reception will start from 6 o'clock next door. So please exit the door, and on the left-hand side, you will find another door. Okay. Okay, so I hope you enjoyed the seminar, and let's collaborate more during dinner reception. Okay, thank you very much.